Okay, let's look at this last problem. It says, what is the smallest perimeter possible for a rectangle whose area is 12 inches squared? And what are the dimensions? So it not only wants the smallest perimeter, so that's the whole thing, but it also wants the dimensions. So let's solve this. First, let's draw a problem so that we can get an equation in one variable. So rectangle. Here's a rectangle. They've told us that the area, so the area on the inside, is 12 inches squared. Okay? We don't know anything else, but we do know that area is base times height. So let's call our sides something. We don't know anything about the sides. We don't know anything about how much we're using for the sides or anything like that. We only know the area. So we need to call our sides X and Y or B and H or whatever you want to do. So from there, we know that our area is going to be X times Y, and they told us our area is 12. So we have 12 equals XY. Here is our constraint. So that keeps us from having a million answers. What we need is the smallest perimeter. So if we look at this, we know that both of these sides are X and both of these sides are Y. So if we want the perimeter around this rectangle, call it P, we would have two X's, 2X. We need to add two Y's, plus 2Y. We need one variable. Right now we have X and Y. So we're going to use our constraint. You can solve for X, you can solve for Y, whatever you want. I decided to solve for Y. So Y will be 12 divided by X. This is what I take and put into my perimeter so that I can have an equation in one variable. P equals 2X plus 2 instead of Y, going to write 12 over X. So my new equation for the perimeter in one variable is 2X plus 24 over X. So let's take the derivative of this. Smallest means we are minimizing. So from here, we can take the derivative. So perimeter equals, we have 2x, so that's the derivative, so we have 2 plus 24 over x means that we have 24 times x to the negative 1. So to take the derivative, we'd have negative 24 times x to the negative 2. So instead of plus, we'd have minus 24. I'm going to rewrite this as a fraction, so this is 24 over x squared. There's our derivative. What we need to find are our critical numbers. To do that, we set this equal to 0, 2 minus 24 over x squared. And we have to multiply because you can solve this, but it's hard to figure out because that x squared. So let's get that out of the denominator. So we're going to multiply by x squared. So 0 times x squared is 0. 2 times x squared is 2x squared. And then this cancels. This is the whole point. X squareds cancel and I just have 24. This I can solve, no problem. Add 24 equals 2x squared. Divide by 2, so x squared is 12. And take the square root. X is the square root of 12. Yes, normally our square root would give us a positive and a negative, but we can go ahead and rule out that negative because reasonably we cannot have a negative measurement. So that goes with our reasonable domain, thinking about the context of the problem. So we'll take this square root of 12. That is one of our dimensions. So x is the square root of 12. Generally, whenever you get one number, you are talking about your derivative and you found your critical number and they're asking you to minimize. Whenever you have one critical number, it's generally assumed that that is your minimum. So you can go back and do your first derivative test, knowing that you don't want anything above or below 0, because we can't have negative measurements. We have the square root of 12, which is about, put that in your calculator, you get about 3.4. So to pick numbers on either side of that, you could choose 1 and 4. When you plug those into your derivative, if you plug in 1, you do get a negative. And if you plug in 4, you have 2 times 4 squared, which is 16 times 2, which is 32 minus 24, you get a positive. And this is decreasing to increasing, so this is indeed a minimum. You can check it, but generally when you have just one critical number like this, that is going to be assumed to be what you are looking for. So that's why we can go ahead and say x is, whoops, scroll back up, x is the square root of 12. So from there we can get our perimeter and y. Probably get y first, because to get our perimeter, it'd be easiest to plug into here. So to get y, we can say that y is 12 over x. So that is 12 over the square root of 12. 12 is technically square root of 12 times square root of 12, so y will just leave over a square root of 12. So both of our dimensions are the same, square root of 12, square root of 12. Then from there we can get our perimeter. Our perimeter is 2 times square root of 12 plus 2 times square root of 12. So 2 square root of 12 plus 2 square root of 12 is 4 square roots of 12. And there is our minimum perimeter. Let's see if they've given us any dimensions to write our final answers. So our perimeter is just one dimensional. There's nothing crazy going on, so we are just going to put inches on here. So that's our minimum perimeter. So we've said what is the smallest perimeter. We need to make sure that we're giving the dimensions clearly. So one dimension is square root of 12. Don't forget your units. We've already decided they're inches. And our other one is square root of 12. Don't forget your units. We've already decided they're inches. So here are our final answer, the minimum perimeter and the dimensions that go with it. Yes, I do.